This is the first part of the notes for section 12.2 on chemical calculations. This one's dealing with mole ratios and one-step mole-to-mole conversions. So in chemical calculations, mole ratios are used to convert between a given number of moles of a reactant or product to moles of a different reactant or product. Mole ratios right up here, those are that's a key concept. They'll be in every different stoichiometry problem that we do. We get the mole ratios from the balanced equation. We have to look at the coefficients. So this equation, for example, you have 1 mole of N2O5 and 1 mole of H2O. That produces 2 moles of HNO3. So you have to look at the coefficients to find the mole ratio. Using that same balanced equation on the previous slide, these are the different mole ratios that we come up with. There's 6 different possibilities. A mole ratio, it's always moles of one substance over moles of a different substance, and the numbers come from the coefficients in the balanced equation. So if it's HNO3, there's going to be a coefficient 2 right there. So that's what mole ratios look like, and those will be used in the problems that we do. The first type of problem that we'll look at, it's a mole to mole conversion problem. It's just a one-step conversion. We have our balanced equation right up here. You always need a balanced equation to work with. This is the problem that we're given. And down here at the bottom, this is a general format. In each problem, we have something that's given, and that's going to be labeled G for given. And we have something that we want to calculate, and that's going to be W for wanted. And the general format shows what the conversion factor is going to look like to get from what's given to what we want. Same example, I just put it on a notepad so I can write on the screen. So we have 4.5 moles of O2, and that yields how many moles of H2O? So what's given is going to be the 4.5 moles of O2 right there. That's our given amount. What we're looking for is how many moles of H2O that gives us. So to start off the problem, we go with 4.5 moles of O2. That's our given quantity. All right, so that's where we're at down here. Now for the conversion factor, it's going to look like this. It's going to be moles of what we want over moles of what we start with. B and A are the coefficients in the balanced equation. So if we look at the balanced equation, we want to find H2O. We're given O2 to begin with. So the coefficient for O2 is 1. Again, if nothing is written there, it means 1. The coefficient for H2O is 2. So our conversion factor is going to look like this. Draw the line. It's going to be 2 moles of water over 1 mole of oxygen. That's the setup right there. Okay, what's given? This is our mole ratio right there from the balanced equation. So now for the math, we just cancel out the moles of O2. 4.5 times 2, 9.0 moles of water. Okay, and that's a one-step conversion problem. Here's the other example from your notes. We have a different balanced equation up here, and now we have 0.5 moles of FeCl3 yields blank moles of PbCl2. So what's given is going to be 0.5 moles of FeCl3. So that's going to be the starting amount right there. So that's going to go in that place. What we're looking for is moles of PbCl2. So that's where we're going to end up right there. That's the conversion factor that we have to set up. So what we want is PbCl2. We find that in the balanced equation. That's right there. It has a coefficient of 3. We're going to use that. Okay? And then we have FeCl3 as a starting point. That's right there. That's a coefficient of 2. We're going to use that in the mole ratio. So we start off 0.5 moles FeCl3. Okay. All right. Now I set up the the mole ratio. So it's what we want over what's given. So we want the PbCl2. So that's going to be 3 moles PbCl2. Okay? And what's given, what we start with is FeCl3. So that's going to go on the bottom of this conversion factor. So 2 moles FeCl3. Kind of a messy 3. It's all right. So now we do the math. We cancel this out. Moles of FeCl3 go away. So now it's 0.5 times 3 divided by 2. So our answer is 0.75. Now it's moles PbCl2. And that's our answer. So again, these are one-step conversion problems. That's the first type of problem that you're going to see.